Hello everybody. In this video we will learn how to use the Twincat program, using the Grafcet system. This program is used for Bechkoff PLCs. In this image you have an example. In the video we will do something similar. We will start from an initial point, giving it an input. It will act step by step. In each step a light will be switched on, and in each stage there will be a 3 seconds waiting condition. Between stages 3 and 4 there will be a bifurcation, creating a second path. Some stages will be activated more than once. We will use a counter and make the system run 3 times for some stages. After doing this work, the program will end and we will return to the main position, waiting for a start signal. First, open the Twincat application. Then, click on New Twincat Project. Everyone will choose where to save the file and also what to call it. We will select the default template. Now we will check different aspects. First of all, that we are working locally. In this case we will not use any physical PLC. What we will do is to program and simulate in the same computer. On the other hand, in the left section, we have the information about our project. If we click on PLC, we have the option to program. Right-click and select Add New Item. Then we select Standard Project. In this way, under PLC we will see different folders. In our case we will only use the GVL and PU folders. In GVL we will create the global variables. These can be used in the future if we use physical PLCs, connecting physical inputs and outputs. In the PU folder we will make the program. First we will create the variables. To do this, right-click and add Global Variable List. We will create a list of all the variables. In this page we should create all the variables that we will use. If you don't know how to insert variables, a trick would be in the top right-click, select Auto Declare. Say what variable it will be. Define its name and also its type of variable. In the address, as the program will be simulated on the computer, we don't need it. But, here we would have to put the code of the physical inputs and outputs of the PLC. In this case we will program it for the future. As the button in a digital input we will write the following code. Once we have programmed the variable, we will have it in the list. To create more variables, we can follow the previous steps. We can also copy and paste the code of another variable and edit it. In this case we will create the outputs, which would be the lights. To do this we will copy the code of the previous variable and the only thing we will change will be its name and address. As the button is an input we have designated the code I. Nevertheless, as the lights are output signals we will have to put a Q instead of the I. We will put I for the input variables and Q for output variables. Repeat 4 times to create all the output variables. Now we will create the program. Inside the PU folder, we will find the main. Here we will program our main program. In this case, the program, by default, tells us that we have to program using structured text code. That is how computer scientists do it, writing all the code. To change it we have to do the following. right-click on POO and giving it to the add, we will select POO. This will be of type program. At the bottom, select the type of language, in this case, SFC or Grafcet type. We can also select different styles like street, structures text, or also ladder type. This is mainly used for Siemens machines. We will select the Grafcet type and open it. As the program will always execute the main program, what we will do is to call from there to our program, where we will execute our Grafcet. To do this, we put the name of the program, in this case POO. We open and close the parenthesis and that's it. We go back to the POO program and we start to make our program. On the right side you have a toolbox to add accessories. Or right-click on the initialization block and choose it. The first step will be to add the stages that we will use, creating the skeleton of the program. To do this, hold the left mouse button and drag to where it is placed. We will also add the transitions between the stages. To create the fork, click on the point where the second path will be made and select Insert Bracket. On the second path we will add a jump. The skeleton is almost finished. The program will be as follows. At the beginning we'll set it to run. Then we reach the first stage and wait for 3 seconds. Then consecutively it will do the path and wait for 3 seconds at each stage. After the cycle 3 times, it will finally reach the end and will be in the initialization stage, waiting for the start button to be pressed. To set where the jump is to be directed, do the following. Click on Jump and what you have to do is to define which stage you want to move to. To define what action each stage will perform, select the action box in the toolbox and drag it to the corresponding stage. If we click on N, we will see that we have different letters. The ones we are interested in are N, R, and S. N is used when the actions are only executed when the stage is activated. If we use S, set, the actions remain active even though the stage is no longer active. They will remain active until another block is activated with R, reset. In this case we will leave all the stages with the letter N. Here we will have to set which outputs we want to activate with each stage. For this we will put the previously created variables, type GVL. And the whole list of variables will appear. We will do this with all the stages. Now we will program the conditions for each stage. For the start we will use the variable corresponding to the start button. We have defined the condition for the program to advance to be 3 seconds between each stage. For this we will use a counter. We will create inside the program a variable called T1. It will be of type time. This will have a value of 3 seconds. To use it, we will make a comparison. Each step block has different functions inside. If we write step 0. Different functions will appear. The first one would be the rising edge of the timer. The second, the rising edge of the signal. The third one, the timer. And finally, the signal. In our case, we will select the third one and compare it with our time variable. Even if we write, it will not be seen, but then it appears. The condition would be, if the inner relay of the stage is equal to the value of our timer, T1, then it is active, otherwise it waits. We will copy this condition for the rest of the condition. Note that each stage must be given its own number. If nothing else is done, the cycle will be performed only once. What we want is for the cycle to be performed 3 times, sending the signal through the branch. Then we will have to create a condition so that the program performs the cycle several times. To do this, we will have to create a counter. On top of the POO, we will right-click and add action. In this case, we will use the ladder language. Select the CTU block, a counter that adds positively. Hit enter and accept. To program it, you have different options. With CU we define with which signal we will increment the value, with reset with which signal we will reset it, with PV we define how many times we want to count and when the Q signal will be activated. With CV we can see how many times it has counted. This last value will be deleted. With the second stage we count the turns, and with the third stage we reset. To do this we will use the active signal of each stage, in this case the X. Each time the second stage is activated, a 1 will be added to the counter. If step 3 is activated, it will be reset. We have said that we want to count to 3, so in the value of PV we will put a 3. For the output we will use a coil as the output signal. This will be the output signal for the counter. We will call it contadoria. This will be a Boolean. type. Now we have to implement it in our skeleton. Above step 3 we'll add the counter condition. After the time elapses and if the counter has counted 3 laps, then let it pass and activate step 3. To finish, what we will have to do is to call the counter from the program. For it we will add in step 2 and step 3 actions that are called act, the program of the counter. With the finished program, we will have to check that it works. For this we will make a simulation. To do this, click on the top left, activate configuration. At the bottom, we'll see if we have any errors. And now we'll set our variables and we'll be able to force the variables to simulate the Grafcet. Click on the green square, Login. The simulation is now active, waiting for us to force the values. In the prepared value column, type the desired state and click on Force Value. This will make the selected variables change their state. First click on Start Simulation, green arrow. The cycle has already started. To see how many turns it has done, we can look at the counter block, CTU, and if we look at the CV value we can see how many times each cycle has been done. Once the 3 cycles have been completed, the program goes into standby, until the start button is pressed again. Then the program is done. We have learned how to make a program by means of Grafcet. How to insert a timer and make a counter. How to indicate different conditions. And also how to create variables. With all this you have all the material to face your project. What we need to learn is how to use a mushroom to stop the whole system and bring everything back to the initial position. And also how to connect the program with a real PLC, connecting the variables with the physical cards. I hope it has been helpful, and if you have any doubt don't hesitate to ask. Thank you very much and see you next time.